Greetings and welcome to Distiller. In today's lecture, we are going to talk about one of the most important and most useful tools in programming, and that is called as functions. So, we have learned about functions in math, wherein we say that a function, say f of x, or you always write in math something like y is equal to f of x, right? Where you provide a value for x and that leads to some value y, right? Now, this function could have different forms. It could be a linear function, it could be a quadratic function, it could be a trigonometric function, and so on and so forth, right? But the basic idea of a function is that you use a particular variable, and for a given variable you evaluate another variable, the value of another variable, right? And that basically is used to map two variables to each other, right? So that's a function that you study in math, right? This function could be a single variable function or a multiple variables function, something of this kind, right? Uh, Functions could also be composite functions where you write some function within a function, right? And so on and so forth. You could write multiple things, and you could deal with multiple problems like these in math, right? So, something similar is what happens with programming as well, where you try to map two variables with each other or multiple variables with each other using functions, right? That's what you do in programming as well. But that's not the only kind to which a function is restricted in programming. So, in programming, there are two kinds of functions that we deal with. The first function is a return type function, and the second function is a void type function, right? The first is a return type function, and the second is a void type function. In the return type function, the function always returns a particular value, right? The function always returns a particular value, and therefore, uh, okay, I'll talk about this. And in the void type function, it does not really return a value, it just performs an operation, and that's it. It does not have to return any value, right? Now, an implication of that becomes that a return type function. So, whenever you are dealing with functions in programming, so you have to define a function, okay? And after that, you have to call a function, right? So, you first define a function, and after that, you call a function. So, in order to define a function, you use def. Def is the keyword that you use to define a function. And after that, you write the name of the function over here. And then within parentheses, you can put the variables that you want to pass into the function, right? So just like in math, we say y is equal to f of x. So here x is the variable that you will put in this parentheses over here, right? That's what you're going to do. Okay. So, and this variable, by the way, the one that you pass into a function, this variable is known as an argument. Okay. So a function can have single argument, it could have multiple arguments, it could have no argument as well, right? So we'll talk about various such functions as we go ahead with our lectures. But yeah, the variables that you pass into your function are known as arguments. So here you write arguments, okay? Inside the function name, you write your arguments, okay? Now, as I told, there are two types of functions. There are return type functions and there are void type functions, right? So if it's a return type function, the last value, the last line in the function would end with a return keyword. All right. It would end with a return keyword and it will have to return some value. Now, this value could be a single integer, a float, a single data type, or it could be a list, it could be an array, it could be a tuple, and so on and so forth. So it could be anything, but it has to return something, right? This kind of a function is known as a return type function. Okay. Now, since a return type function is returning a value, um, it is a good practice to store the value that it returns into a given variable in your code. All right. So you say variable f name and the arguments, whatever you're going to pass in. So what this does is it basically this thing where you write the name of the function and pass some argument to the function. This thing is known as calling a function. And if you store that in a variable, it would actually, the variable var is going to store the value that has been returned by the function fname, right? So as we do more problems, you will get more clarity on this, but this is something that I want to start with uh, so that you get more familiar with these functions, right? So this is how you deal with a return type of a return type function, right? So this is a return type function. Okay. Then there could be a void type function. Okay. So in the void type function, in the definition of the function, you don't need to have the return line over here, right? You don't really need to have the return line over here. It would perform some operation and that's it, right? And since it doesn't return any value, the void type functions do not return any value. You don't need to store it in anything. So this is how you call a return type function. All right. You just write the name of the function and within the brackets, you put the arguments. All right. So this is how you call these two different types of functions. And of course, this is how you define the two different types of functions, right? So today we are going to talk about how to define various functions and then how to call them. And with more and more practice, we'll be very familiar on what exactly to do while defining and calling functions, right? But the basic idea over here is that while defining a function, if it's a return type function, you need to end it. The last line of the function should have return in it, while a void type function does not need to return any value, and therefore it's a non-return type function, right? This what do you say? This bifurcation is not very necessary with Python, of course, but with other programming languages, you really need to declare what kind of a function it is, whether it is a return type function or a void type function. So it's a good idea to understand the difference between the two. So the objective of this set of lectures is not just to give you an idea of Python, but also to introduce you to some basics of programming. So if you learn more complex programming languages like C, Java, C++, you don't really struggle as much. So you'll have some basic concepts in your mind, and then you could very easily switch to these programming languages. So that's the idea. And that's why it's a good idea to get familiar with the two different types of functions, return type and void type functions, right? So let's now do certain examples where we use, let's say, a return type function, right? So I'll maybe just erase this part. And yeah, so let's do an example related to a return type function. So over here, we are going to write a function to add two numbers, as simple as that, right? So let's say DEF that starts defining a function. EDT is the name of the function, and A, comma B. And since this is a return type function, you have to return a particular value. So you return the sum of the two, right? Okay, that's very simple. And then when you're calling the function, you could just say, you could store this value in some function. So C equals to add 2 comma 3. So now you store this value of the sum of 2 and 3 in the variable C, and that's it. Now you can do whatever operations you want with the variable C, right? So now if you write C over here, that's just 5, right? And if you add, let's say 5 and 6, you will get another value, which is 11 over here, right? So basically the first value 2 is assigned to the variable A, while the second value 3 is assigned to the variable B, right? Now, since this is a this particular function requires two variables. If you just pass a single argument, let's you say add 2, it will show an error that there are two arguments required, but we've given only one, which is why it would show an error. But let's say you want that even if I pass a single argument, that value should be assigned to say A, but the value of B could be taken as a default value, right? So basically, if I say add 2, it could add 2 to a default value of B, let's say 3, right? So if we do, if we say something of this kind, B equals to 3 in the function definition itself. So what it would do is it would treat 3 as a default value for B, right? So if now we write add 2, what it does is it assigns the value that we've passed to the variable A, while it treats the other variable B as like it assigns the value 3 to the other variable B. So this becomes the default value of this variable. So let's say if I write add 7, so it would just add, assign the value 7 to A and then add 3 to it because the default value of B is 3, right? And let's say if we decide to change the value of B, let's say we say add 7 comma 10. So it would assign the value of 10 to B. But the main idea behind doing something of this kind is that we can provide a default value to this variable B. And that actually is very, very important. It is very useful. This is something that I have very often used. So it's a good idea to have this thing in handy, how to assign a default value to a particular variable, right? You could also, now there could be functions where you have multiple variables. So you really might not remember the positions, or you might be confused a bit. So in that case, you could also do this, that you could say add and then assign the value. So let's say A equals to 2, B equals to 5. You could do this as well. And that very well assigns these values 2 and 5 to the variables A and B, right? So if you, let's say, do something of this kind, let's say B equals A equals to 8, this for instance. So this as well gives you a result. So over here, we've switched the positions. We've assigned the value of B first and we've assigned the value of A later. So it still would have assigned the value 2 to the variable B, while it would have assigned the value 8 to the variable A, right? Because we've called it this way. So these are various ways of calling functions and assigning variables to them, right? So this is a simple example of a return type function, right? If you have a void type function, it would perform some operation, but it doesn't really have to return a value, right? So for example, if you want if you want a function to, let's say, uh, add all the values in an, or sorry, let's say you want a function to just maybe like edit an array. So for example, if you have a list, for example, 1, 2, 3, and you want a function in which any list that is passed, this particular function should be able to append a value 4 to that list. That's it. That's all you want to do. And this list doesn't have to be returned. It just changes the list on its own. So we could do that. So we could say def, and let's say edit is the name of the function. We are going to pass an array to it. And then we could say ar dot append 4, right? So that's it. That's all that we need to do. So now, since we've already defined the array 1, 2, 3, if we call this function, it would not return any value. But then when you check the array, it would have appended 4 to this array AR, right? If we would again call this function, now it would append 4 to the updated value of array. So the new AR would be 1, 2, 3, 4, 4. Let's say you have another array 1, 5, 6, right? And you call the function b, edit, and then you check the array b, it would have appended 4 to this array, right? So this is an operation that has been performed, but it did not really return this thing, right? It did not have to return the array, right? You just want this to keep on appending something to my array, right? This could be done for multiple arrays, right? So let's say I have two arrays, AR1 and AR2. So AR1, it would append 4. AR2, it would append, say, 10. So you could just call this function edit, and you could say AR comma B, right? So now AR has been appended by 4 and B has been appended by 10. So you could do all of these operations without really returning anything to this, like without really returning this thing, right? So that's all that this particular function would do, right? So these are the two types of functions: return type function and the void type function. So maybe if we go back to let's say one of our tutorials where we uh, did all of this. So this is the previous tutorial, series and parallel reactions. So we here we did multiple of these operations, right? So for example, over here, we created what is called as the rate array, right? Now, or let's say we created the rate array over here, and after that we multiplied that to my the stoichiometric matrix, right? So what we could do is we could define a function which creates a rate array, and because this rate array did not really have to be appended or anything anytime, so all we need is this function f, this array f. That's all that is needed from for us. So that's why what we could do is we could just define our let's say RHS, right? This is what it is, RHS. And what it is getting as inputs is um, the rate constants and the concentrations, right? So we could maybe have a rate constant array, a concentration array, and of course the stoichiometric matrix, right? So these three things are necessary for my rate calculations, right? Now this entire thing, I could just take it back into this RHS over here, right? And in place of K1, I could have K0, K2 would be K1, K3 would be K2, and K4 is going to be K3, right? So basically our rate constant array is just K1, K2, K3, and K4, right? That's it. So this is K1, this is K2, and so on, right? So that's all that we need. And after that, we have to perform this operation over here. And we have to return this thing, right? We have to return the matrix multiplication of these two. So return matrix multiplication of R and S, right? And finally, we just call this, and since now this is a return type function, so we need to store the value that has been returned. So we just say RHS K, comma C, comma S, right? That's it. And this does my work, right? This does my work. Similarly, you could also maybe not do all of these operations again and again. So you could just write, let's say another function, define edit. And over here, you are going to edit the concentration array and the time array. And that's how you're going to edit them, right? And of course, you need DT and you need F for these this editing as well. And that's all. You don't really need to do anything else, right? And now you can just call the edit function here. Now this is a void type function, so you don't really need to store the value in any variable. So this would just append my concentration and time arrays, but it would not really really need to be stored anywhere, right? So that's it. And we've got this answer once again, right? So this didn't really have any, we didn't really have any issues with this calculation. So we can do a bunch of these calculations. We can do many such operations by calling these functions again and again, right? This is especially very useful. The functions and everything is especially very, very useful when you do multiple equations altogether, or when you do root solving algorithms and so on. You actually use functions very often. So we'll talk about them in subsequent lectures as well. But hopefully today we have got some idea on how to define a function, how to call a function, what are the types of function, and of course how to use those functions in various problems that we work on. So hopefully we are clear with this, and we'll discuss more about functions, and we'll apply functions to various calculations and various problems that we end up doing in subsequent lectures. Thank you.